You are walking through the forest and notice a flying squirrel is flying from tree to tree in a triangular pattern. The squirrel starts off at tree A, where he has his stash of nuts. You see him jump to tree B, where he drops off some of his nuts. The squirrel then jumps to tree C to mark his territory to warn other squirrels. Finally, the squirrel jumps back to tree A and enjoys a delicious feast of nuts.
The distance between tree B and tree C is 17 feet. The angle formed at tree A is 64 degrees. The angle formed at angle C is 38 degrees. Find the remaining distances between trees A and B and A and C. This problem can be solved using the law of sines. And first you're going to want to find the remaining angle, which is angle B. This can be done by taking the sum of the angles of a triangle, which is 180 degrees, and subtracting the two other angles, which are already known. Doing this work, you should get that angle B equals 78 degrees. Now you can use the law of sines, which says that the sine of any angle in the triangle and over its corresponding side is equal to any other sine of any other angle in the triangle over its corresponding side. So the first one to do is sine A over side A is equal to sine B over sine B, or over B. And when you plug in the numbers for this, you get sine of 64 degrees over 17 feet equals sine of 78 degrees over B. After cross-multiplying and dividing by sine of 64 degrees, it is determined that side B equals 18.50 feet.
Now, to find the next side of side C, you're going to use the same formula, except replace sine B over B with sine C over C. You'll then use the same sine A formula for sine 64 degrees over 17 feet, but instead it'll equal sine of 38 degrees over side C. When this is all multiplied out by doing 17 feet times sine 38 feet divided by sine 64 degrees, you'll get side C equals 11.64 feet. That is all.